Hi guys, this is Mrs. Gastler, and in this video we're going to talk about pulses and waves. So let's get started. So waves and pulses are traveling energy. And what that means is that we've got some energy and it needs to get from one place to another. And the way that it can do that is by traveling in a wave or a pulse. Well, there's other ways to do that too, but we're going to talk about waves and pulses today. It's important to note that only the energy is traveling, and so we're gonna elaborate a little bit more. So remember that they transfer energy from one place to another. What causes them is some kind of disturbance. Okay, it could be a tapping or a push or shove, something falling, any kind of disturbance. If it happens only once, a single disturbance, we call that a pulse, and it might look like this. There's only one single pulse is a pulse, okay? And if it happens multiple times in a row, consecutive disturbances, it might look like this, and that would be called a wave, okay? A bunch of pulses together make a wave, okay? So that's many, okay? So there's one, it's a pulse, many makes it a wave. So how do those things transfer the energy? Well, there's a couple of different ways that might happen, but it really happens because things are connected, okay? And there's two ways that we're going to talk about, and that is transverse and longitudinal. So in a transverse pulse or a wave, what happens is the particles are moving across the wave or the pulse, and that's kind of what I've already drawn up there. So it looks like this. Okay, so the energy is traveling, say, to the right here, right? And the particles are going to go up and down. Now, if the particle or the waves are going up, then the particles might go left and right, but either way, it's going across. So this is the one that looks like a traditional wave that you might be familiar with, that up and down as it goes to the side, okay? A longitudinal wave you might be less familiar with. This one is where the particles move along the wave. Okay, but you've probably seen one of these somewhere before. If the energy is moving to the side, just like in the transverse wave, the particles also go back and forth to the side along the wave. Okay, longitudinal along the wave. Transverse is across the wave. Along the wave and across the wave. Let's see. Along the wave, across the wave. That's the way I remember those, okay? And what that looks like is kind of hard to draw. It looks like this, okay? If you did the Exploring Waves lab and you did the station with the slinky where you pushed to the end and you saw that compressed little area move along the slinky, that is what a longitudinal wave looks like, okay? It's hard to draw. Do your best. Draw some lines close together and some lines farther apart and close together and farther apart. Redraw it if you have to, cross it out, take a picture or something like that. You can do it. So that is what a longitudinal wave looks like, okay? So there you have it. Longitudinal, transverse, those are our two waves, how waves and pulses transfer energy. If you had one disturbance only, that is a pulse. Lots of disturbances over and over again, that's going to be a wave, okay? Let your teacher know if you have any questions. Thanks for watching.